It's Dr. Jake. I wasn't able to finish all of 2.6, the other types of equations. So here we are for the finale of 2.6. We'll call this other types of equations, part 2. In particular, we're talking about radical equations, also known as square roots. Now, there are other types of radicals, which we'll learn about in Chapter 3. But for Chapter 2's material, we're going to specifically talk about the square root, which is sort of the mother of all radicals. Unfortunately, we're in the same situation that we were in the first part of this lesson. You can't trust your answers. You just really can't. You could do everything right. You could follow all the steps. You could not make any mistakes, and still your answer could be incorrect. Yeah, that's just the nature of this business. So we're going to have to check every solution. Okay. Make sure the candidate, that's what we call it, is true. Or in other words, results in a true statement. Okay. Before I actually solve any problems, let's just talk about whether or not something is true or false. In the last part of the section, or the first part of this section, we were talking about rational equations, and a rational equation is typically false, typically when you divide by 0. That's the main thing that causes a rational equation to be false. I mean, there are some other things that could go wrong, but the main thing you're looking for in part 1 is dividing by 0. With square roots, what you're looking for is something a little bit different. So let's just look at an example. The square root of 9 is 3. Is that true or false? Well, that's true. How about the square root of negative 9 is 3i? Is that true? Yes, that's also true. I need a napkin. How about, let's see, the square root of 4 is negative 2. That's false. Yeah. Now this one can be kind of tricky because you might remember, from basic math that negative times a negative is a positive, and you could, plug in negative 2, multiply negative 2 times negative 2 and get 4, and you might think that it's true, but this is simply not true. Okay. The symbol square root we assume to mean the principal square root or the positive square root, and so this is actually a false statement. So this is what we're looking for when we're checking our answer. All right. If this type of thing happens, it's not always going to be a 4 and a 2, but something like that. Let's do another one. The square root of negative 4 is negative 2. That's also false. Okay. That's false. The square root of negative 4 is not negative 2. How about negative the square root of 4 is negative 2? That's actually true. Yeah. So really what we're looking for is false statements when we check our answers, and it won't always be a 9 or a 3 or a 4 or a 2, but those are very common square roots. They're easy to just remember. 2 times 2 is 4, and 3 times 3 is 9, and things like that. Okay, So keep your eye out for falsities that sort of look like they could possibly be true, but they're actually false. Let's go ahead and solve some equations and see how it goes. Check our answers. Example 1, solve for x. The square root of x is equal to 5. By the way, let's call this part A because I think I have room to do a couple of these on here. The square root of x is equal to 5. So we're going to square both sides. Okay, we're not going to square root both sides. We're going to square both sides. The square of the square root, those are inverses of each other. They cancel each other out. This is sometimes called extracting the root. Sounds like a dental term, doesn't it? Extracting the root. Yeah. So that's now an x. Yeah, it's no longer x squared. It's no longer the square root is just x. But on this side, you're going to square it, and you're going to get 25. Don't trust this. This is called the candidate. Yeah. If you want to make sure it's true, you have to check it. Always use the original problem. All right. Don't use the simplified version. Use the original problem, which was square root of x equals 5. Plug in your candidate where x was. And check that this is in fact true. So it is in fact true. Good. So the valid solution is 25. I could keep this going. How about square root of x is equal to -3? Square root of x is equal to -3. Just call this part B. Square both sides. Extract the root. -3 times -3 is 9. This is your candidate. Don't trust it. Check it. Square root of x is equal to -3. Plug in your candidate. I always think of it like you're giving it an interview. Right? You want to check it out, make sure it's actually valid, and we'll give it an interview, ask it a question. So x becomes 9. Is this true or false? If you remember the warm-up, this is false. And this sometimes drives people crazy. If this drives you crazy, you're not the only one. Because people remember from basic math, well, -3 times -3 is equal to 9, so why isn't this true? And the reason is really one of semantics. When you write down the symbol square root, you have to assume that we are talking about the principal square root. This is not the principal square root. This is what we call the other root. Okay. Now, if there was a negative outside of the square root, then that would be true. Yeah. So this candidate is a liar, so there is no solution. We say DNE when there's no solution. Does not exist. All right, well, that's really just example 1 to kind of get the ball rolling, get you used to what we're going to be doing in this section. For the rest of these problems, they're going to be a little bit more complicated. All right, I just want to make sure you understand what we're looking for when we check. So in the next one, solve for x. the square root of x minus 5 is equal to 4. Okay. By the way, a lot of these problems have the same first step. The first step is to square both sides. I will mention in a few minutes when you cannot do this first step. There might be some problems where you have some preliminary steps before you can actually do this. But as long as the square root is isolated, and it's on one side of the equation, you can just jump right in and square both sides. So you're going to extract the root. Make sure you don't accidentally square the x and square the 5, because you're not squaring the inside, you're squaring the radical. And when you square the radical, the inside, the radicand, comes out. We call that an extraction. It's like pulling out a tooth. And then just keep solving it. You're going to add 5 to both sides. And you get x equals 21. That's your candidate. Don't trust it. Check it. Use the original. All right. Don't try to check the other version of the problem. Check the original problem, the way it was written in the problem. Plug in your candidate for x. (21 minus 5 is 16. Square root of 16 is 4. Check. That is in fact true. Yep. So if it is true, it becomes what we call a valid solution, or you could just say solution. It's no longer a candidate. Yeah, it gets promoted to a higher level. It's now the solution. That's pretty much it, you know. You're going to not want to check. I know. I'm a person just like you. I've got better things to do than sit around and check every single answer that I get, right? But the one time that you don't check, that's going to be the one time that it's on the test. That's going to be the time that it ends up costing you more than you can afford to do it. So, yeah, I mean, you just got to do it every time. It's like a seatbelt, right? I mean, I don't really want to wear my seatbelt either, but you got to. Or these days, it's like the mask, you know. The one day you don't wear the mask, you know, that's the day that someone's going to sneeze on your face, you know. So you got to wear the darn mask every day. All right, so let's keep on rolling. So we got 8 times the square root of x plus 10 plus 3 is equal to 4. Now, this is the exception. Pretty much from here on out, starting with example 3, you must first isolate the square root before you square both sides. So you have to isolate first. So you want to get rid of the 8 and you want to get rid of the positive 3. Make sure you do your adding and subtracting first. When you're solving an equation, it's like I don't know if you remember from elementary school, we used to call it, please excuse my dear Aunt Sally. That's when you're simplifying. When you're solving, it goes the other way. Adding and subtracting first, then multiplying and dividing, then square roots and exponents and things like that last. All right, so you work backwards. Divide both sides by 8. All right, now you've got it isolated. Isolated means there's no external additions, subtractions, multiplications, or divisions. It's just an isolated radical. So now you're ready to square both sides. Extract the root. Be careful, I almost screwed up. my timer going off. 1/8 squared is not 1/16, it's 1/64. 8 times 8. 8 times 8. 64. I literally almost put 16 because I was thinking about something else, so be careful. And now you're basically home free. Just move the 10 to the other side. I'm going to multiply by 64 to get an LCD. And I'm going to get negative 639/64. And you know what sucks about this is not even the solution. This is just the candidate. Hit the red button. Okay. Should we trust it? I wouldn't. I wouldn't trust it. I would check. So you've got 8 times the square root of x plus 10, plus 3 equals 4. Make sure you use the original problem. Take your candidate and plug them in and see what happens. So I've got a negative 639 over 64 plus 10 plus 3 is equal to 4. All right, so I plugged in my x here. I know you're going to wish it was easier, but it's just not. All right, you could just trust it. Say, yeah, I trust you. Yeah, but it's a bad idea. You will get burned, especially in these types of equations. It's one of the reasons why we call them radicals. Yeah. So you got negative 639 over 64 plus, we'll multiply this by 64 to get an LCD. So this is going to be 8 times the square. There's an invisible times here if that helps you. You don't have to put a times symbol, but whenever you put a number in front of a radical, you assume that means multiply. That's the implied operation. You're going to get 1/64 plus 3 equals 4. The square root of 1/64 is 1/8. 8 times 1/8 is 1. And that is, of course, true. So, you know, we could have trusted it. This is one of the times where I would have got away with it, yeah. But the next time, you might not get away with it. So you got to be a little bit more careful. Okay. And so that means the valid solution, or you could just say solution is negative 639/64. That was correct. Okay, moving right along. Example 4. Square root of 3x minus 14 plus 9 equals negative 1. Oh, I hate when this happens. Come back to me. Come back to me. There we go. Okay. Now this time the multiplier, the coefficient, is inside the radical, so we're going to leave it there until the very end. But we do have a plus 9 on the outside that we need to get rid of. So we got to get rid of that first. Now we don't have to worry about the 3 or the 14 because they are inside the radical. And be careful when you're subtracting. We get a lot of trouble with students with basic math. It happens all the time. In fact, if you catch my mistakes are typically basic math mistakes as well. It's just one of those things that never goes away. You know, everybody makes the same mistakes. So that's a negative 1 and a negative 9. Be careful you don't accidentally put negative 8, right? It's negative 10. It's like It's like a credit card. Yeah, you spent $1 and then you spent $9, and so your total amount on there is $10. Now the cool thing about algebra is there's no interest. All right. So you're going to square both sides. It's going to extract the root. And now we'll deal with the 3 and the 14 after we've extracted it. Okay, so I got 3x minus 14 is equal to 100. Add 14. Get 3x equals 114. Divide both sides by 3. Anybody know what 114 divided by 3 is? It's 38. How did I do that in my head? Well, 3 goes into 11 3 times. Yeah, 3 times 3 is 9. Remainder 2. So now you have 24. 3 goes into 24 8 times. If you can't do mental arithmetic like that, that's okay. All right, I do this all the time. All right. So you do have a calculator. Use it if you need it, but avoid it at all costs. All right, just only use it out of absolute desperation when you have no other choice. I go like this. I've had it up to here. I've had enough. And then I use my calculator. So this is candidate. Sometimes my brain just gets tired too. You know, a brain is just like anything else. What am I going to do? You know exactly what I'm going to do, aren't I? Don't you get annoyed with this, don't you? Don't worry. When this section's over, we'll never have to do this again. But we will always remember the lesson we learned: radicals and rationals. Never trust them. All right, go all the way back to the beginning. This is the original problem. We're going to check. I want to check whether, make sure that it comes out to be -1. So we're going to put our candidate in there, 38. That's our x. Don't mess around with it, right? If you mess around with it, you might turn a false statement into a true statement, and that's still not going to be legitimate. So you can't help it along, right? You just have to sit back and watch it, and if it's false, it's false. You know, if it's true, it's true. Let it tell you what it is. Right? You don't have to mess around with it. It's like nature. You just have to watch. All right, 3 times 38 is 114. So you get 114 minus 14 is 100. Square root of 100 is 10. 10 plus 9 equals -1. That's false. So there is no solution. The solution is DNE. 10 plus 9 does not equal -1. So that's just false. That suck. Yeah. When I found out, you know, I don't know about you, but when I first learned math, I was under the impression, I'm talking like, 25 years ago or something. I was young. And I thought that math was this perfect subject where as long as you did everything right and as long as you follow the steps that, it always gives you the right answer. But that's a myth. Yeah, math is a human subject. And so it's fallible. It could lie to you. It could tell you the truth. Right? You could follow all the rules and do all the mathematics perfectly, and still you get no solution. You get DNE. That's just the nature of the subject. Okay? So we just accept that fact, and we work within the system that we have. We do the best we can with what we got. Yeah. And sometimes you just hope for it to be over, right? When's this going to be over? Well, don't be in too much of a hurry, because when it's over, then what? Yeah. All right, come back to me. Come back to me. My next example. The square root of 10 minus x plus x is equal to 8. And I'm just going to hope that my Come back down to me. There we go. Nice. Autofocus. There we go. All right, moving right along, moving right along. We're going to follow the same set of procedures. So we're going to move this x onto the other side because it's outside the radical. So it needs to vacate, needs to move out. And now on this side you have 8 minus x. Now be careful that you don't accidentally write x minus 8. Sometimes the brain will write what it thinks you mean, but that's not what you mean. You mean 8 minus x. That's what you mean. All right, and off we go. Yeah, next step, square both sides. Now, one of these sides is going to be very easy. That's the left side because it has the radical. The right side's not going to be so easy. You must write it out twice. If you try to just take this 2 and put it in there, that will always be wrong. All right, every single time. If you take your exponent and try to plop it inside, that is always going to be incorrect. It is never going to give you the right answer. It is tempting to do it because it's really easy to do it, but it's always the wrong thing to do. Write it out twice and do it the long way. Remember that old saying when you were growing up, if it's too good to be true, it's not true. Yeah. And my friends, that is too good to be true, to be able to just put the exponent in. That's just an unreasonable expectation. So 8 times 8 is 64. 8 times negative x is negative 8x. Another 8 times another negative x is another negative 8x. Notice those are both negative. And a negative times a negative is a positive x squared. All right, so now we have a quadratic equation. Let me put it in standard order. X squared first. Then I'm going to combine my 8x's. That's going to be negative 16x. And then I'm going to put my plus 64 at the end. Now remember, quadratic equations were covered in a previous section, 2.5. We must move everything over and set it equal to 0. So we're going to add x to both sides. Why don't we go ahead and kill 2 birds here with 1 stone. We're going to add x and subtract 10. That'll automatically give us 0 on the left-hand side. And now we have a much easier equation. It's x squared minus 15x plus 54. I don't want to forget this guy, so I'm going to write it up here. The original problem. Now you have the luxury of having it on your screen, so when you're done, you can just check the problem that's on the computer screen. But if this were a paper test, I would never, ever want to erase that step. Although I guess if it was a paper test, you would also have the problem on your paper test. So I guess what I'm saying really doesn't make any sense. I'm just talking. Okay. I think I've mentioned this before. I like to solve quadratic equations right-handed, probably just because I'm a right-handed person. So we often move the equals 0 to the right-hand side of the equation simply because it looks nicer. There's no mathematical reason for that. It just looks easier that way. Or not. I mean, if you think it looks easier on the left, then by all means, leave it on the left. Yeah. So you have x and x, 2 numbers that multiply to be 54. Remember my promise, they're always going to be nice factorable numbers like 9 and 6. I'll give you a little hint on the homework or on the test. If you don't get a nice factorable problem in this particular type of problem, I'm not saying forever. I don't want you to misinterpret what I'm saying. But for these types of problems, I promise I will always give you a nice factorable number. So 9 and 6, and they should both be negative. Right? Be careful with signs. Negative times a negative is a positive, and a negative plus a negative, 6 and 9 is negative 15. So if that doesn't work, then go back and check. You probably made a mistake, kind of like I've done in the past, where I've caught my mistake. And I'll be totally honest with you. The only way I caught my mistake is that I knew that I had made these problems all factorable. And so when I saw a problem that wasn't factorable, I went, oh, shoot, there's got to be a mistake somewhere, right? All right, I should shut up and just finish this problem. So you got x minus 6 equals 0, or two candidates, x minus 9 equals 0. It's one of the reasons why we say or. There's no guarantee that they're both going to work. So we get our candidates. And we have to check them. I wouldn't trust them. I wouldn't trust them. Yeah. So sometimes they both work. Sometimes only one of them works. Sometimes it really sucks. None of them work. Yeah. It's no fault of your own. It's just none of them work. That's just life. Yeah. All right, let's try this one. So this would be square root 10 minus 6 plus 6 equals 8. Square root of 4 plus 6 equals 8. 2 plus 6 equals 8. Check, check. That one's good. Okay. Let's try the 9. Square root of 10 minus 9 plus 9 equals 8. Make sure you don't do one of them as a 6 and one of them as a 9 at the same time. That will never be true. All right? It's got to be one candidate at a time. Like they get separate interviews. Square root of 1 is 1. 1 plus 9 does not equal 8. That's false. So the only valid solution is x equals 6. And that's it. You only get one valid solution, x equals 6. I don't know what else to say. You know, you do the math, you follow the steps, you be careful, you get your candidates, and then you check your candidates, and you never know what's going to happen. I actually, personally, I thought the 9 was going to work and the 6 wasn't, so I'm not very good at predicting. I mean, you can make a prediction, but I would never trust your prediction. You know, I've had students come to me and say, oh, you know, Dr. Jordan, I noticed that whenever this happens, then this is the solution, whenever that. And I'm fine with that. If you notice something and it helps you make an educated, you know, guess or estimation as to what you think's going to, then that's fine. Go with it. But don't trust it. All right. Just what I recommend is if you have that intuition, something tells you that you think you know, that's fine. Go ahead. You know, document that. Put it down, but don't trust that. Actually work it out and see if what you think actually connects with the truth, you know. Right? It's easy to think you know, and then it turns out that you don't know. No. That's just the nature of this subject. Example 6. This one's already set up for you. I gave you a few of these. It's I've done all the prep for you, and all you have to do is jump right in and solve it. All right. You don't have to move anything from one side to the other. You just automatically have one ready to go. So this one's ready to go. Dive right in and square both sides. The left side, don't take the bait. Don't put the 2 on the inside, exponent. You got to write it out twice. On the left side, the right-hand side extracts. Be very careful. Do not actually go 2 times 2 and get 4. Do not actually go 7 times 7 and get 49. When you square a radical, it kills only the radical and extracts what's inside, called the radicand. Distribute. If you're really good at this, you can probably do all of that mentally. Depends on how often you do math, how long it's been, how good you were at it last time you took this class or a similar type of class. Turns out that most algebras are the same. Beginning is the same as intermediate, which is the same as advanced, which is the same as college. Yeah. It just gets harder and harder, but the math itself is the same. So if you're really good at this, you can jump right to here if you can do it. I do not want you jumping if you're going to fall. If you can't make the jump, then just don't try the jump. Or maybe try it, but don't rest on it. Don't, subtract 2x from both sides. Subtract 7 from both sides. Remember what Dr. J told you. He said these will be factorable. If they're not factorable, you probably did something wrong. Oh, no. What the heck is going on here? Oh, it's a perfect square. The only way to factor a 9 so that it also equals 6 is 3 times 3. There's only one way. Yeah. This means you're only going to have one candidate. This is what we call a repeated root or a repeated solution. Yeah. Although it's technically not a solution until you're done, but we call this a repeated root. When that happens, you don't have to solve it twice. Just solve it once. I don't need 2 copies of the same answer. It's one answer repeated twice, but you only have to give it to me once. Okay, that's our candidate. Let's go ahead and test it. X plus 4 equals the square root of 2x plus 7. Test it out, make sure it works. What's our candidate? -3. So -3 plus 4 equals the square root of 2 times -3 plus 7. -3 plus 4 equals 1. 2 times -3 is -6. 1 is equal to the square root of 1. True. So this is a valid solution. X equals -3 is a valid solution. It checked out. All right, 2 more. Example 7. Square root of t plus 1. Oh no, I'm getting crazy now on you. Different variable. If that bothers you, you can just call it x. It means the same thing. Equals the square root of t plus 13. Again, this one is all set up for you. It's ready to go. Yeah, this one's ready to go. There's nothing outside the radical. There's no multiplications. There's no divisions. There's no additions and subtractions. The radical is completely isolated. So you can jump right in and square both sides. And again, be really careful. The right-hand side is easy. This is what we call an extraction. Squaring a square root extracts the inside, the radicand. The left side, you have to actually write it out. I know, you don't want to. I don't want to either. But you have to. Square root t plus 1, square root t plus 1. When we do word problems, we like to use t for time. So it's just another version of x. And now you have to multiply this sucker out like this. So you get square root t times square root t. That's the square root of t squared. I'll cancel that in a minute. Square root t times 1. That's 1 square root t. You do not have to write the 1 if you don't want. Another 1 square root t. And then 1 times 1 is 1. Over here, you can cancel the square root t squared and just get t. That extracts. Be careful in the middle. These are not opposites. They do not cancel. They combine. 1 plus 1 is 2. 2 square root t. I want to set this to 0. Yeah, set the right-hand side to 0. So I'm going to go minus t, minus t. Oh, that's nice. Those guys cancel out. All right, I said I was going to set it to 0, so I will, but this is not a quadratic equation, so setting it equal to 0 is not required, but I already opened my big mouth, so I'm just going to go ahead and do it. So now I've got 2 square root t minus 12. If this was a quadratic equation, I would factor it like I did in the last example, but it's not quadratic. It's radical again. Yeah, it's still a radical equation. So this is a lot like example 1 or example 2 that I did, I don't know, how long has it been, 30, 40 minutes ago. So you're going to add 12 to both sides. Divide both sides by 2. And it's a radical equation, so you're going to square both sides. And you're going to get 36 as your candidate. All right. Had this been a quadratic, if it looked like, t squared or something, then I would use factoring. One thing you need to be careful with is how you say it. Some people say squared when they really mean square root, and vice versa. Some people say square root when they really mean squared. So, those words are very similar. They sound similar. They interact with each other in a very similar way. We use them in conjunction with each other, but they are not the same thing. A square root is different than a square. Again, I'm not going to trust my answer. I'm going to check the original problem. Always use the original problem. Plug this guy in here and here. And I always just hope it's right, because I do not want to have spent that much time of my life and having it be wrong would be awful. Yeah. Can you see that it's true? If you see it's true, you can stop right now. It's true. Maybe you want to go one more step. 36 becomes 6. Yeah, the square root of 36 is 6. 36 plus 13 is 49. And 7 does equal the square root of 49. That is true. So this is a valid solution. You need to be careful when you check your answer. I've seen students, especially on tests, they will get an answer, they will check their answer, and then they will accidentally give me the answer as 49 or maybe 7. This is not the answer. This is the validation of the answer. The answer is 36. The solution is 36. So be careful. If you check your answer and it's right, and then you give me the wrong answer, it's like, oh man, I wish you had checked. In that case, I wish you had checked. So this is called the confirmation or the validation. This is called the solution over here, 36. Okay, I got one more example, and we are done with this section. So, it's been a long week. You've probably watched a lot of hours of videos, and you've probably been doing a lot of homework this week. So don't worry, it'll pay off. This time that you put in will pay off. I will reward you. Last one, example 8. Square root of 14x minus 6 equals 2x. I gave you a lot of these. I like you guys. I want you to do well. I want you all to succeed. So I gave you a lot of these problems that are already set up, but there's a few that aren't. So when you're doing your homework, watch out for the ones that are not set up for squaring right away. The key thing to look for is look to see if the radical is already isolated. If the radical has no other terms outside the radical, it's ready to go. You can just jump right in and square both sides. Okay. And so you get 14x minus 6 equals 4x squared. Be really careful. 2 times 2 is 4. X times x is x squared. Set this equal to 0. I'm going to go minus 4x squared here. Okay. I promise that this will be factorable. Okay. If it's not, then you did something wrong. It looks like they're all multiples of 2. And we also have a negative leading coefficient. So they're all divisible by 2, and we can pull out a negative. Be really careful when you take out a negative, because that 14, you're dividing it by a negative. So a positive divided by a negative becomes negative 7. And the 6, you're dividing it by a negative. So negative 6 divided by negative 2 is positive 3. And I'm really telling myself that as much as I'm telling you that. Right? Divide both sides by negative 2. Okay. Factor these guys out. I don't know, many of you come from a variety of different backgrounds. Some of you have had a lot of math. Some of you, it's been a while. Some of you might have, not had math in a long time, or maybe when you had this, you never quite learned it. So if you have to, review factoring, meet with me online on Zoom, or meet with my TA online. Sheila is really good at teaching factoring. She's got some tricks that she's actually taught me. Like, I didn't know that trick because I learned it, 25, 30 years ago, and I just kind of always do it the way I do it. So this is my method. Look at the first term, 2x times x. Ignore the middle term. Look at the last term, 3 times 1. And I don't care if this is right or not. If it's not right, I can always fix it. And I don't put the plus and minus signs right away because I can always change them if I don't like them. All right? If I can put them in such a way that I can make it correct. So I want two numbers that multiply to be a positive, but add to be a negative. So now I know they both have to be negative. And there you go. Now you should check your factors to make sure that you get negative 7 in the middle. All right. It's not that hard. Just multiply the outside, 2 times 3, or 2 times negative 3. All right. That's negative 6. And then the inside, negative 1x is negative 1x. So in your head, when you're checking the factors, you have negative 6x, negative 1x, and you want to check that that is in fact negative 7x, and it is. Check. That's correct. Check. That's correct. If it's not correct, then come back here and guess something different. All right? It might take 1 guess, 2 guesses, it might take 10 guesses, but I promise you, I will give you a problem that is possible so that eventually you will get it, even if you have to guess 100 times. God forbid it takes 100 times. All right, remember the ZPP, the zero product principle, or the ZPR, the zero product rule. You have 2 candidates. One of them's, let's do the easy one first. X minus 3, that one's easy. That one's just going to be positive 3. Okay. The more complicated one is a fraction, 2x minus 1. You're going to add 1 and divide by 2. Okay. There's a term that I use when I don't have enough time to do something and I want you to do it. I say DIY. DIY, you know what that means, right? Do it yourself. I'm all out of time, folks. So check these, do it yourself. They're both correct, I promise you, they're both correct. Okay. So if they're both correct, they're both valid, I want you to list them. X1 is the smaller one, and X2 is the larger one. Yeah, so smaller one goes on the left, larger goes on the right. All right, so those are your 2 solutions. They are, in fact, valid. You should check me. All right, if I'm wrong, I'll give you some extra credit for the first student that finds my mistake. All right, I've got a list I've been keeping. I hope it doesn't come to that. You know, I don't want to make mistakes, but you know, I'm still a human being. There's not much I can do about that. All the math in the world won't scrub the humanity out of me. Okay, folks, that's it for 2.6. Until next time, see you on the internet. Bye-bye.